What's up, nerds? Harbinger here. I'm going to do the first video in a series of two. The two-part mini-series here is going to be on the theory and the application of nested loops. I really think it's more fun to do the application first because it relies on some of the visuals and it relies on some of the turtle graphics drawings that we've been doing. And then the theory follows that, if you can see how to do some of these things, maybe you understand some of the underlying fundamental principles involved. So this video is going to be on drawing stuff, and the other video is going to be on like nerd stuff, I guess to say it nicely. I've already done this video twice and had a couple issues. So this is iteration number 3, and hopefully this one does the trick. So forgive me if, I feel like I've done this before. Deja vu is happening right now. Anyway, on my screen, I imported 2 different packages, turtle and random. I declared a turtle object and I made it go really fast. And then this comment here is the colors of the rainbow, kind of. I turned yellow dark just because it's easier to show up on a screen. I'm not using it yet, but I do want to use it soon and thought it was just easier to have it ready that I could uncomment than doing all of it for you guys. You don't want to waste time just watching this. For turt in range 25 is a loop that runs 25 times. I'm going to pick on that one program we did in the previous lab where it's some randomly placed squares. If I had to say it out loud, it would be a turtle draws a square, and then maybe let me reverse that. A turtle picks a random position in terms of X and Y. Pen up, warps there, pen down, then draws a square, and repeats that. So I'm going to do that right here. My turtle is going to 25 times do that exact thing. Poof. He says, and it fails. Poof, he does, and paste finally works. I picked 2 random integers between -150 and 150. So I picked an X and a Y coordinate at random. I picked my pen up, and I clicked Go To, and now I'm going to put my pen down. You can tell where I left off in my other video where things started to break down with like phone calls and emails and software and everything else. So now that my pen is in place, I'm going to draw a square. Previously, you guys did something like T dot forward 80, T dot RT 90, and then you did forward and turn and forward and turn and forward and turn. And now I'm suggesting maybe that because it's a randomly placed set of squares 25 times, I'm going to do a loop inside of a loop. And some of you who did this already, good for you. Like you saw that you could put a loop in a loop. And I'm really happy for the people that did that. So forward, and I don't know how much you want to move forward, like 60 or something like that. And then I'm going to do my right turn of 90 degrees. So this is going to, looking at my inner loop, draw a square. And the outer loop says, well, first pick a random spot and let's warp there. And we'll draw a square. And we're going to do that 25 times. So what I could do right now is click and it does that. And that's nice. Let's see some kind of like cool modern art. And now I'm going to just add in one nice little feature just because. It doesn't have to do this. I just think people like how it looks. You don't know this per se yet, but this is like an added little bonus. I am going to change the color of my turtle, and I'm going to make it a random color. So what I do is I'm going to turn the turtle's color to a random choice from the list of calls, right? From my colors list up here. So now when I do it, it looks like that looks prettier. So dark yellow is getting a whole lot of love there, so it's blue. But if I do it again, it should be random again. I don't really care about the color so much when you do the lab. I care about the idea behind it. But let me expand this a little bit. I do care about the idea that there's a loop inside of a loop. And if you do this in a different way, you don't get credit. I can't just look at the picture and go, oh, right, they got this. Because how do I know you didn't do 100 lines of code or something like that, or maybe like 200 lines of code, where it's a lot of copying and pasting, where you picked 2 numbers and then you drew a square, and you maybe have no loops. So you're an awful person, but kidding. You're just an inefficient person. And I feel like this does it efficiently. So one more time, looking like that. That's nice. Okay, I'm going to do it a little bit differently now. I'm going to completely delete this. Sorry if people get upset because I'm deleting good code. I'm going to do it what's called like a top-down approach. if I came to you in the first place and said, hey, how do you draw that stuff on the right? How do you draw all this over here? You'd say, oh, you pick a random position, and then you pick a random color, and then you draw a square, and you repeat. You'd say, okay, well, how many times do you want me to repeat? And they would say something like, let's see, pick position. I'll call it pick pause. And then after pick position, then I draw a square, not random color, rand color, and then draw square. So this is called pseudocode, right? I'm mixing English and computer science stuff, like Python code. And this is called the top-down approach because I've got my big ideas in place, and then I'm moving down levels of abstraction. So draw square is not defined. Yeah, I know. I haven't defined it yet. Let me define it. Def. Pick pause. So how do you pick a position? Well, I would x equals random dot rand int negative 150 to 150. Then I'm going to do the same thing for y. And I also have to do the pen up and pen down thing. So t dot pen up and t dot go to and t dot pen down. Lee is yelling somewhere like, it's just up and just down. You don't need the pen stuff. I know. I'm going to move these guys up here. Just the Java in me makes, I feel better doing that. So I declare my turtle object, then I can talk about it. It's not even the Java in me. It's more like a C++ thing. But, oh, well, hey, I picked a position. Now what? Pick a random color. So I have to define rand color. Right? So I could do calls down here, but I don't have to. I could do something like t.color, let's see, random choice calls. So it's a one-liner. It doesn't really add to the functionality, but people can kind of see where it comes from. And last but not least, they said, what is it, like draw square? Yeah, draw square. So how do I draw a square? When I want to draw a square, I do something 4 times. So for sid in range 4, I'm going to move it forward like 60. And I do a right turn because I'm right-handed, but I've seen some people do left turns. Kind of wonder if they're left-handed or not, but whatever. So now what I'm doing is, hey, I picked a random position. I could choose a random color. I could draw a square, and I could do this at any point in the code. If I have a whole lot more code down below, I can still call draw square. I can still call random color. I can still pick a random position, not just at this point in this loop. So I've kind of added to the functionality because these are general actions for any point in the code that asks it for help. So I'm going to run it again to make sure. And of course, I didn't do it correctly. All the people that were yelling like 2 minutes ago, like, you forgot the colon. Yeah, I'm good like that. I forgot the argument there too, but not the first, not the last mistake I'm going to make. Hey, it works. Awesome. So that's the top-down version. That's cool. If you really want to make it nerdy, you could specify like an incoming number. And this is a nice way of saying, hey, if you ever want to draw a square, it doesn't have to be 60. I can now draw a square of any size, right? So it could be like, I could feed it a 10 down here, and it's going to draw little squares. And I could feed it 100 and have it draw big squares. Right now it's going to draw a little one. Ooh. So if I fed it a bigger thing, it could be like 80. And now they're going to draw big squares. So that's cool. Heck, some of you who are clamoring for like random, 10 to 70 kind of thing, we could do that too. So it's neat when you can, it's called like give it an argument, give it an input. Hey, my input is coming in here, and whatever the input is, go forward that much. And my input here is randomized. But that's just me, like showing off. You don't have to do this. Okay, so what I'm going to do now is I'm going to go back to the way I had it originally, because now I want to do a different thing. And if you want, you know what? I want to keep draw square. I just don't need pick pause, nor do I need random color, I guess I'll keep it around just in case. But what I'm going to do now, I don't want to draw a randomly sized square. I guess I'll do something in a second. Show you what I'm talking about. So what I'm going to do is I'm going to draw like, I don't even want to tell you yet. I don't want to ruin the surprise. So what I really want to do is set it up like this. I hope you're thinking right now, I wonder what he's doing. So let's talk about it before we run it. I'll tell you what's going to happen. If it's Harbinger usual code, it means it's going to look really cool and then crash and burn and then nothing works. But on the off chance that it works, here goes. These are predefined functions, so I don't really have to think about them right now. The code itself, when it runs, it makes the turtle and makes it fast. Then 25 times, I'm going to pick a random color, and I jump up here, and I'm like, okay, I got a random color. Now what? It's like, oh, go draw a square. Go draw a square of variable size plus 10, and it's not a random variable. It's based on the loop step variable. So initially, SQ is really small, and it climbs up to 25. So it's going to draw a small square, and then a bigger square, and then a bigger square, and a bigger square, and then we get something that looks pretty cool. You know, like this. Ooh. So I like that a lot. I'm glad we put the random color in there because it looks pretty cool. But what I do is I feed it a variable input. And if you're not doing the draw square with the num parameter in there, that's cool. You don't have to. If you had like 4 SQ in range, if you wanted to instead, you could say 4 sides in range 4. You could do this. And instead of draw square, I'll hashtag this out, he says with a smile. I'm going to do SQ times 5 plus 10. And then I'm going to do a right turn. So if you're not comfortable doing functions yet, and people aren't, to be honest, I mean, this is like a brand new weird thing, and you don't have to learn it for this lab. But my hope is that you read this code and you're like, hey, 25 times, I'm going to pick a random color, and this is the code to draw a square, except for you, the big step is going to be instead of doing like a set side length over and over and over and over, the side lengths of the squares are going to get bigger. So now when I do it, it's the same thing, just I didn't call the draw square function. Okay. How can I make this worse? You know, because I'm good at like making things worse, right? So I did this one in class today, and the students are fantastic, of course. So I'm going to do, if you saw what's happening graphics-wise, it's moving a little bit slower. That's because I kept the draw square in a loop, which the function itself runs a loop. So it's drawing like 4 squares on top of each other, and then it makes a little bit bigger set of 4 squares on top of each other. I don't need this loop right here. So I'm kind of combining concepts. Let me run that again. That's faster. So my last question is, how does all this change if I added 1 line of code? So how does that change if maybe I turn a random color, I draw a square, then I turn a little bit and do it again. So instead of having this like weird stacked squares perspective, they're turning as they draw. That looks neat. So what happens if I added more squares to it? What happens if I made like 100? Same size squares at each stage, just in this case they get bigger because there's more of them and we're spiraling out. So this looks pretty funky, but you know, there's a limit at which it stops kind of making sense, which means I should probably tighten up the spiral. And by doing that, I'm going to change my right turn amount. So I'm going to say something like 10 degrees. Now I should have a tighter spiral. So as you can see, it gets really close together. You can actually see the kind of spiral approach to it, which is pretty cool. And by playing with the parameter of the right turn, you can actually get a smaller and smaller thing. Heck, what if we don't make the square blow up even as big? Like, what if I don't want it times 5? What if I want it times 3? Or something like that. My squares, in a sense, should be really small. So, funny, I just picked like 7 purples in a row. That's kind of neat. So I'm not going to ask in a quiz, hey, how do you make a tighter spiral? How do you widen it? How do you, do whatever? I'm not quizzing you on spiral drawing, but it's a really fun feature to play with because you have a lot of numbers you could be messing with right now. So one last, because I think it seems like fun. So that whole thing, which was like 15 minutes long, was how to draw squares a lot, how to draw squares in a different way, how to draw stacked squares, how to draw spiral squares. So the lab is going to follow on stuff like this. I'm not going to make it terribly complex, but maybe you can think about how to make a repeated pattern repeat, if that makes any kind of sense, because we can do a lot of fun things with repeated repetition. You don't have to do functions for what we're about to do, but it helps. If you wanted to copy my draw square function, you're more than welcome to. If you wanted to copy the random color thing, that's cool too. Because again, I really am pushing the idea of repeated repetition here. And on video number 2, we're going to be doing more of the theory stuff with what a nested loop means, what happens with variable management, and how do you deal with memory. So just be careful because that one too, there's a lot of ways to get it wrong. Here, the only way to get things wrong traditionally is to not indent correctly or something like that. So stay tuned for video 2. I'll see you guys soon. Harbinger out.